Alright, welcome back to Meteorology 101. Going live again, and we're going to look at this system moving through the Midwest. It's a pretty intense low pressure system. You can see the rotation on the national radar, and got these bands of precip. It's kind of pushing out away from the center of that radar. There's right around the center of that low. You got looks like minor short waves just kind of traveling around that low. What you have is a baroclinic system in its mature stage right now, and what I would look for this thing to do is just kind of stall out, and it's been a slow moving system the whole time. Just kind of stall out over the Great Lakes region and just sit there and fill from the bottom up, and then that low pressure disappear on the surface. Uh, Still be able to see it at the 850, 5,000 feet, and then just fill from the bottom up, and these minor short waves just kind of moving around this low pressure system and just getting on and off rain showers for a little while. So let's see what happens there. We'll pull the surface chart and maybe some local radar. We did get some tornado warnings in South Carolina, North Carolina today, and then some marine warnings, special marine warnings all along the coast of Florida. So you can see a pretty good line right there moving through Florida and just pretty much getting intense right over that warm water. So we could pull up the local radars, and right now I'm in North Carolina, Virginia. That's where that tornado warning was earlier. Like I said, there's no warnings now. We have one, and that is a special marine warning for the coastal waters right around Florida. There's the tornado warning we seen earlier. We had reports of wind damage. We actually, over in Ohio, there was a report of a funnel cloud in eastern Ohio. Let's get a look at this thing real quick. Stop that loop, do a cross section. These things weren't very intense. I mean, we did have tornado warnings, but our heights weren't very high. We were about 25,000 feet for the tops of this thing, overshooting up to 25,000. I mean, our tropopause hangs out right around 25, 30,000 feet, so we did get a little bit of overshooting tops there. But yesterday, those storms were pushing through. They were pushing through to about up to about 40, 50,000 feet. So, and the high reflectivities were pushing all the way up to 30,000 feet. So we had a real intense storms yesterday. All that stuff along the Gulf Coast. So this time, yeah, still some rotation indicated by radar, prompting those tornado warnings. And like I said, there was a funnel cloud in eastern Ohio. Let's see what get rid of that cross section there. See if we can get over to Ohio real quick and see if that shows on a history radar. Probably won't see anything on the radar. I think it was just a train spotter reported a funnel cloud. Get the loop downloaded. Alright, being a little slow. Alright, I'm going to go ahead and let's pull up the surface chart real quick. See if we can get that radar to come up. There it goes. Alright, so we're not showing the funnel cloud. Pretty much goes back past the earliest loop shot on this loop, so we're not seeing that right now. Alright, we got that low pressure centered over Illinois, and then you can see the troughing pushing down through Kentucky, Tennessee, Alabama, possibly a cold front coming out of that low, and just wrapping right around that high pressure system into this low pressure, and then warm air advection right along the Gulf Coast still. So some more, looks like a prefrontal trough stretching down into South Carolina, Georgia, off the coast of Florida. So that's probably all those lines that are popping up once it hits that weaker area, the area of lift in that trough. Then you're getting those lines of thunderstorms there. And then a little bit of ridging pushing up into North Carolina, not too deep into North Carolina to stop that. It's probably capping that all that moisture. That's why we're only seeing that moisture go up to about 10,000 feet on the higher reflectivities. So that high pressure is just ridging in a little bit there and capping that off. So the updraft really can't push all the way up to the upper levels, just having an issue getting up there. So close low on the surface. Pull up the isotherms, we'll see still a baroclinic low. So once this low pressure system becomes like these isotherms become parallel with the isobars, then we'll see that become more barotropic and start to fill from that bottom up. We'll pull up some models, see how that turns out. So a lot of times these low pressure systems just follow the jet, push off to the northeast, and then just wrap around back up into Canada, and then they just go up there to die. Let me get some surface plots on here. Keep an eye out for any other warnings popping up too. So if any warnings come up on the radar, we'll shoot over there. Running a little slow today. Alright, so we can see the rotation around that low pressure system is counterclockwise. Clockwise around the high. This is a high pressure system over Wyoming. That's a little intense for that being a high pressure system. That high is there, that high center, but the computer data is just kind of taking this thing, taking a little too far. There's probably one station in there plotting a little bit higher pressure than the rest of them, so it's kind of interpolating that data and creating just such an intense high over the upper elevations right there. So kind of ignore that. I'd put definitely probably put a high there just based on the wind directions. And then I wouldn't put the pressure gradient that tight. I mean, we do have a 25 knot wind to the north of that high. Everything else about 10 to 15 knots. So we've had a pretty windy season so far. Like even around this high pressure system, or the low pressure, we're 10 to 20 knots. I mean, we're pushing 20 knots from the north in Illinois. And then you get to the center of the low where there's really no gradient, but the winds travel counterclockwise and into a low, so you can see these winds push into the low. You get the low level convergence and then upward vertical motion as that low pressure, that mass goes vertical, then this high pressure has to push into that to fill that in. So that's where you get the winds rushing into that low pressure. Just winds always blow from high to low pressure. All right, we put some fronts on here real quick. And then we can start going up in the upper levels, look at the development of the system. These are computer-generated fronts. I mean, there's a lot of warm air advection over the Atlantic off the East Coast. Cold air advection right coming out of that low, right behind that, the high pressure behind that low. Not a lot of gradient going on there, but you can see the northwesterly flow and then becoming southwesterly. So you can see our front is going to be right between those, and you got a 73 degree temperature versus 65 behind the front. So the placement of that low is pretty close, and then it's wrapping around, like I said, back into that low pressure system. As that low pressure system rotates counterclockwise, probably should have a little bit of warm air advection on the east side of that low, and then the cold air coming back off of that back over toward the west. So these maps get a little cluttered when we put these fronts on here, because it doubles the highs and lows and kind of places stuff where it wants, but gives you an idea where the fronts are placed. Now through this mountain range, with that high pressure system ridging into North Carolina, you have that little bit of ridging there. You know, high pressure off the East Coast, you got the warm air trying to push that out of the way, and it can't. So it's kind of just, that's why these fronts kind of drop down and they start getting that you get that damming effect, and the warm air has to stay on this side of that high because it can't move it out of the way. That high pressure rules. The high pressure has to move out of the way. This warm air just pushes up against that high and then lifts, and you can get that lift with that frontal system, and that's where you can get that instability and get the lift that you need. So moisture, instability, and lift, the three ingredients for weather and thunderstorms. You can get the thunderstorms, and then depending on how strong that lift is, how strong the updraft is, and if it's going to be severe, how high those higher reflectivities can be pushed up into the upper levels. So, like I said, with those higher reflectivities at the surface on the radar, let's get back over there real quick. You're not, we're not going to see any hail. You're definitely not going to see any hail with this because, I mean, you got moisture above the freezing level, but you just don't have the concentration of moisture that you need to be pushed away up in the upper levels, and then an updraft strong enough to hold that into the upper levels, and then for the ice to collide and become bigger, and then big enough to fall through that updraft. This updraft's so weak that it's just it can barely hold up those raindrops, so they're falling out. So if you get up any hail at all, that would fall, and then it would most likely be so small that it would just still fall as rain and melt before it hit the ground. Alright, so we're still over Ohio there. Let me get rid of this cross section sitting here trying to drag my screen over, and that ain't working. Alright, so if we get back over to North Carolina, Virginia, let's get this loop back up, and we maybe get a better look at that, any convection in these areas. Actually, let's go on down to Florida. Let's just drag it down there. We know we got that pretty good line right there off the East Coast. I don't know why I'm lagging behind tonight. This is just insane. Alright, I'm going to let that radar load. We're going to go back over to the charts. Alright, let me get the 850 pulled up. We'll run an 850 chart real quick, and then we have to make a few changes here. There's the moisture at 5,000 feet. Probably got some other moisture at 5,000 feet. This is probably a little bit older data. Alright, I'm going to go ahead and erase that. We're going to do a balance chart. And this is going to define these highs and lows a little bit better. So I want to get a good look at that low pressure system over Illinois. See if it's kind of becoming more vertically stacked, or if it's stacking back into Iowa. If we get that stack, then we got jet support, and that's still a bare clinic system. Then it's still in its mature stage. So at that point, we're not looking for anything to stall out, and become more vertical and die out. That's what lows can do, but if we're still stacking back toward the cold air, we're not going to see that happen just yet. Alright, I'm going to jump back to the radar. I'm lagging on these things when I'm loading these graphics. I guess this live stream's slowing me down quite a bit, so I'm going to go back over to Florida. We're off the east coast of Florida. We see a pretty good line there. We'll see if we can get a got a couple shots, it looks like. So try to download the rest of this thing for our loop, and then Maybe do a cross section out there. Probably, pretty sure you probably have some water spouts over this morning. I'll pretty much stick to the little bit to the north. I would, with that curvature on that line. Alright, let's go stop this loop. Let's get over to the last shot. Let's do a cross section real quick. See what we got there. It's a little long. Let's go shorter. I just exited out of it. Let's go try it again. Okay, so drag this. Let's get some higher reflectivities. Then we can swing it. Get to the max point of that system. Now we're pushing about 43 dBZs, just over 22,000 feet right there. 50 dBZs, 52 at 13,500 feet. So we are still in the severe area of that. And then looks like this is shooting all the way up to about 40,000 feet. So we can pull the base velocity. See if it's going to turn. Now, if you look at that, we definitely got some rotation throughout the upper levels there. So that's pretty much why they're throwing that warning out there. Let's go back to the surface on this. There's your radar, seeing the rotation, going to the higher degree of the radar, and we have rotation pretty far up. I mean, it's nothing to ignore, that's for sure. But that's why this area is in that warning versus all that stuff to the north. That's all pretty much red. So if we go into the upper angles of the radar there, we don't see any green. So no indication of rotation. All of it's down to the south. That's why all of that is showing within that warning area. So we can do a volume scan on this thing. Get a 3D picture of it, and it's pretty weak. I mean, here, let me go back and put my lower DBZs on this thing too. So there's the whole volume scan. You see a couple overshooting tops right there. So this is a multi-cell, and then that's going up to about 40,000 feet. But the higher reflectivities are at the base of this thing. They're we were saying about just right around 22,000 feet for the higher reflectivity. So, and then 12,000 or so with just in the severe range with the 50 dBZs. So we can go back and we can erase everything all the way up to the 50 dBZ mark. Now there's really nothing in the volume scan now. We back it off a little bit, go into about 45 dBZ. Now we're getting into about 20,000 feet on that. So a little bit of lift there. No major structures. Do have the rotation. That's indicated by radar. So that's why we have the warnings. Could throw a little bit more in here. Greens, blues. Just kind of shaded a little bit, but ain't really doing much for us. Build a little bit of a structure here, so we got. Alright. Let's go get rid of some of this blue. Alright, there's our structure. Nothing really to brag about. Okay, like I said, we do have. You can see the overshooting tops on this volume scan, so that's pretty cool. And then Getting rid of the lower reflectivities. I'm just playing around right now, so see if we can break this thing into different layers. If we can get it to show up in different layers, we can kind of see the different colors through these higher heights. So that's what I'm aiming for. Playing with this radar settings, try to make that happen. Try to pull just the higher parts of these sections of each reflectivity. Alright. Kind of breaks it down a little bit better. Probably want to get rid of a little bit more of that blue. Get rid of all of the lighter blue. There we go. Alright, so there's a 3D structure of that. Nothing to brag about. As the tornadoes hit this season, we'll break these down even more. Maybe do a couple of chases this summer and use this software as we're doing our chase and find out where the best area is to go in toward the storm or try to intercept it. So let me get back out of here. All warnings have expired. There's nothing left. Let's just go over here to that one cell to the north and let's pull a cross section on that real quick. So you can see all the way up to right around 38,000 feet right there, where the tops of that is. But the top of your higher reflectivity thing worth looking at is pretty much right around 26,000 feet, just under 27,000. And then any of the higher severe reflectivities are below 10,000 feet, so nothing to be concerned about for severe weather. So if we do a volume scan on that one, just put everything in there. And that's pretty much the structure of that line. Go get rid of some of this. Okay. Now you can see a little bit of tops right there. So that's pretty much it. Nothing to brag about. Let's go back over to our chart, see if they're done loading. Being slow. So now we got since I changed the settings there, we got that low pressure system that was over eastern Illinois. If we had to place a center on this one, let's go get our isotherms and get our station plots and put those on there. You can see how these lines are becoming more parallel with, well, on the back side of that low, but they were still baroclinical on the east side of that low. So we're still got an unstable system there. That's why all the weather we're looking at mostly is right on the east side of that low, except for everything that's getting that wraparound moisture from that low pressure system just being so intense and dragging that moisture around, and then being an occluded low, you have another frontal system with two different layers there that between the cold and the warm air. So you have an occlusion that's lagging behind the surface front. There's a upper front there too, so it's kind of creating that lift right around St. Louis area and getting that little bit of convection on the west side of Illinois also. Alright, so There's our station plots. You can see the rotation. There's where, on the east side of Illinois, is where we were centered on the surface. Looking at the southeasterly flow, and then the southerly flow going southeasterly all the way to a kind of a, you got an easterly flow there, and then come wrapping back around. So, trying to see, we got a prefrontal trough right here, it looks like, and then this is the upper 5,000 feet. So we got rotation right there over northern St. Louis. That's where I would call that upper level low. So I would put that closed rotation right there. This computer is not analyzing this very good, so I'd pull this contour back around to the west, drag it down, and then I would close that low off right there. Put a low pressure system right there over northern St. Louis. So now northern Missouri, but you got the center of the low over eastern Illinois, stacking back to northern Missouri. Now you still got a stack system, baroclinic. Like I said, this system is still well in its mature stage. So with the jet support, let's go look at a jet stream real quick. And we look at the mid-level flows. We get a 700, 500. You can see that's just going to basically, 700 and 500 is going to be your steering flow too, but it's going to be more of a how fast. You can use those to calculate how fast that system is moving. But the upper levels, your jet stream, that's going to be your main factor on the steering. My camera battery's probably going dead, so I'm probably going to just go ahead and turn me off here, and then we'll continue with the live stream for the charts. So let me get rid of this. Alright, so there's a jet max right over top of that low pressure system. So with that jet max moving basically into this trough, that trough is going to deepen. This system moving out of this ridge, that's going to weaken that ridge. But with the jet max over that system, we have pretty much all of the chimney effect going on we need right now. So basically the winds are blowing over that low and just sucking mass out of that low, keeping it alive. That's why we have such an intense system that we've seen on the radar. Let me get back to the correct radar. If you look at the rotation, the rotation of that low, that's why that is so intense, because the jet stream's blowing right over top of that. It's like blowing air over a straw. You actually create a suction. So when that jet max is blowing, that's max winds. Let's go look at those winds real quick. See what kind of speeds we're looking at that level. We'll throw some pressure on here real quick, and we can see the contours. So we look at our flow, and then get the station plots on here. Now we can see what the balloons have reported. I mean, really, this thing's not a straight line wind over top of that low. This is a rotation looking over that low. I'm going to go ahead and erase this real quick. We're going to start over. Let me do a balanced height chart on this one and see if we can pick up that rotation, because I've seen that on the winds. There's no way those contours are just going into a straight line like that. Alright, we'll do a balanced field. Sometimes it takes a little bit longer to process that data, so I'm going to go back through here. Turn these cameras off. Save my battery. Alright, this is taking a minute. Can pull up the models real quick and see what while we're waiting. Alright, so there's the low pressure system over Illinois. They got that pushing north and east. The models don't know really what it's going to do. Just kind of wobble around there for a minute. Now it looks like the low pressure went away. Now it came back. Kind of did stall out right over Lake Michigan, or over Michigan there, and Lake Michigan. And then those just kind of die out. So we got some cold air pockets dropping up down out of the north. So that's going to create a higher pressure on the surface. Not necessarily a high pressure system, but a higher pressure. So this low pressure did fill that low that was over the, it did just kind of stall over there. But we'll have to look and see what upper level low, what happens there is it fills through the upper levels, and see what this is calling for precipitation. I'm kind of jumping all over. Okay, so it kind of moves out of the way, wanders around there for a minute, dives out, and then looks like high pressure originating from the north. That's on the surface. Still have precipitation over the Ohio Valley region and over, well, not really Ohio Valley, but the eastern Ohio and along West Virginia and the mountain ranges. So that pushing all that moisture aloft with the orographic lift and creating any precipitation there. So the upper level low, if it's still hanging out at this point, filling from the bottom up, because that thing was pretty intense all the way up to 30,000 feet. We've seen that rotation. So I would say just that doesn't have the moisture in those levels to create the precipitation. It is a decaying wave, low pressure, becoming vertical, barotropic system, filling from the bottom up, but just doesn't have the moisture. So every time a short wave goes around that low pressure system, we just don't have the precipitation to fall. So that low pressure system that moved off to the north or over to the east, that got off the coast, and that became pretty intense, just like that line of thunderstorms we've seen off the east coast of Florida. Once they get over that warm Gulf Stream, that's where that they just intensify pretty good right there. So alright, so high pressure drops down, looks like out of Canada. That's out of it is out of Canada. There's another continental polar air mass dropping down there all the way down into Tennessee. Bring some snow behind it. We got up in Montana, Wyoming, some snowfall, northern Minnesota into Wisconsin. This low pressure system kind of looks like a clipper moving across there over up through the north, and then got the wraparound moisture with kind of just staying up in the Canada area. So then we get some convection. Looks like a lee side low or lee side trough. What is that? High pressure dominating, just pushing back through another continental tropical polar high. Looks like dropping out of Canada again. Curious to see what the temperatures are going to be on this. What kind of temperatures we're going to get. Kind of have a mild spring, but there's a low pressure system that just formed right over as a high pressure pushed south, formed right over Texas. It's all the way down in Mexico, eastern Texas. Convection just shooting across the Gulf states again, and they're just going to get clobbered once again. Definitely looks like some tornadoes, severe weather all along Louisiana. See, eastern Texas, Louisiana, Mississippi, Alabama, all the way up into the mountain ranges through northern Georgia and South Carolina. So And then there's another low pressure system that pushed off down into the Gulf. It kind of just disappeared. But now we're getting some wraparound moisture onto a cold, looks like over a cold air mass to the north over New York, causes some snow and some ice. Vermont, New Hampshire, and then all your New England states just getting hit with another ice storm and some more snowfall. So another pretty intense low pressure system there. Like to see that one in the upper levels as it develops also. And then just looks like an unstable wave moving through the central U.S. right over St. Louis area again. This is April 26th on a Monday. Pretty far out there, so take all this with a grain of salt. These models have been kind of not doing a great job. I mean, they've been catching some precipitation, convectivity and stuff, but totally missed a lot of that in this last few days. So keep an eye on all that. See how it all develops. Might have more to talk about. All right, let me get back to our charts, and I don't know what happened here. Get you on the same page there. That's what happened. See that? Alright. I'm not sure what I did there. Let me get rid of that. Trying to do some wind shading. We want to see our jet. I think I was doing too many things at once. Alright, there's the jet max. Now we were doing that balanced height. That's what we were kind of looking for, this low. We were seeing the circulation on the radio sound data, but we didn't. The standard contour analysis wasn't picking that up. So this might take just a minute. I just clicked on some stuff I'm probably going to regret here in a minute. See what you guys are looking at here. I guess this thing's lagging behind pretty good. From what I'm looking at, what you're watching is we're still stuck on the models anyway. Alright, we're waiting for this pressure feed here. Alright, this thing is taking a minute here. Alright, we may have to just go ahead and end this thing. It's not not cooperating. I'm trying to get this I got this there it goes. Okay, it just came up. I was getting ready to close this out. So now we can definitely see that low pressure. It is picking that up now. Right there over northern Missouri. So we had low pressure on the surface on eastern Illinois, stacked back over to northern Missouri, and we still are pretty much vertically stacked now. So like I said, this low pressure system is kind of dying out. It is still in the mature stage. It will become a decaying wave. We watched that on the models, just kind of push, meander around a little bit, and then just fill at the surface. The models just showed the surface. So this low pressure system is closed all the way up to 30,000 feet. So we're definitely going to see this low hang out here for a while, but fortunately or unfortunately, however you want to look at it, there's not enough moisture associated with this in the upper levels to continue that rainfall. So as the rainfall dies out, the low pressure on the surface fills, and then there's just not the moisture is just not present there in the upper levels to continue with the short waves coming around this low and creating rainfall day after day. You know, sometimes if the moisture was extended all the way to those upper levels and hung out there was enough moisture, it would this low would just sit there, and usually stalls out over the Great Lakes region, just sits there and spins for like 3 or 4 days, and you just get rain, on and off rain showers as those short waves just go around that low until it finally fills and then just finally dissipates out. So did take a little while for this data to process to get this right, but this computer system did do it, and it's good to see. So pretty impressive to see a closed low at 30,000 feet like that. As you go up into the upper levels, you can see like where your low center is. Say it was over eastern Illinois, and then of 850 stacks back a little bit more, then 700, 500, 300, and you'll see that stack just a few degrees longitude each at each chart level, and that gives you a pretty good stack system. And then with this jet max over that low, just gives you the support that it needs to, like I said, just blowing an air gun right over a straw, creating a suction and just sucking the mass right out of that low. Anything on the surface, just vacuuming it up, all that moisture, pulling it to the upper levels, and then just getting, pretty intense weather. But the problem here was just the lack of moisture. So 3 things you need for weather is, for unstable weather, I guess, is moisture, instability, and lift. So we had our lift, low pressure system, moisture at the surface, nothing really in the upper levels, and definitely got the low pressure for our instability. Alright, I'm going to end this here. I want to ask you to visit Meteorology101.com, hang out there for a little bit. If you want to learn some more details about weather, if you have any questions, just put them in the comments and give me a thumbs up, and we'll see you next time. Thanks for watching.